recording. So today, last new material we will cover this year. So 14.3, right triangles and trigonomic ratios. We are strictly dealing with right triangle trigonometry today. We are not doing any other kind of triangle trig. You will find next year that you will do trigonometry with non-right triangles, and you will do non-triangle trigonometry, which is extremely useful. Okay, everybody thinks trig's all about triangles. No, it's not. It is extremely useful for triangles, finding areas and lengths and all kinds of neat stuff like that. However, it is also extremely useful for anything that repeats itself. Your heartbeat is called a sinusoidal function, not because it has anything to do with your sinuses, but because it has to do with a regular repeated pattern. You can actually model a healthy heartbeat with a calculator, with a computer program using sine functions. Okay, anything that repeats itself is what trig is really good for, because that's what it does. Okay, so a few things you're going to be working with today: Pythagorean theorem. I certainly hope by now you've got the Pythagorean theorem down pretty good, because we're not going to go over it in detail. A squared plus b squared equals c squared. SOHCAHTOA, these are your right triangle trig ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. SOHCAHTOA. The way I remember it is not saying it, I remember it by this. Some old hippie caught another hippie tripping on acid. So sine, opposite over hypotenuse. Cosine, caught another hippie. Cosine, adjacent over the hypotenuse. Tangent, tripping on acid. Opposite over adjacent. It works. Part of the reason I don't like SOHCAHTOA because students often remember if they say so and co, they forget the H for the hypotenuse. Okay? But you'll never forget hippies. You'll always remember the hippie. Okay? Now, cosecant. Can an elephant drive a Cadillac? Cosecant. Okay. Really? It's not that. Okay. No. Okay, here's the thing. Cosecant, secant, and cotangent are inverse trig functions. There are two ways to think about them. If you have a right triangle, the cosecant of an angle is the inverse of the sine or hypotenuse over the opposite. You can also think about it as 1 over the sine. The secant is the inverse of the cosine. So it is the hypotenuse over the adjacent, or 1 over the cosine of theta. And the cotangent, that's the easy one to remember. It is the inverse of the tangent. So it is the adjacent over the opposite, or 1 over the tangent of theta.
So it's just 1 over.
Yes, but you're not going to use the 1 over. Well, you will use it with the calculators later, but you also need to know the ratio of the sides of a triangle. Standard labeling of a right triangle. You have your 3 angles, A, B, C. C is always the right angle. Uppercase for the angles. Lowercase is the length of the sides opposite those angles. That is your standard labeling of a right triangle. 3 letters for the vertices, capitals for the vertices, lowercase for the sides. The sides and angles opposite each other are the same letter, just upper and lowercase. Standard labeling procedure. Okay? Questions? Yes.
On the CSC, 0 was the second part. So
Shh, quiet.
this is height over hypotenuse.
Hypotenuse over sine of theta. This should be the sine of theta. Theta is, this is theta, by the way, this in case you forgot from your geometry, that's theta. Theta is the most commonly used variable for an angle. Okay, use theta all the time whenever we're talking about angles. X is the most common variable, but when we're talking about angles, theta is the most common variable for an angle measurement. Okay, and you need to know what theta is. And this is sine, not sin. Sine is what we talk about in math class. Sin is what you talk about in church. This ain't church. We don't talk about sin, we talk about sine. If you say sin, you will make me angry. This is cosine, not cos. This is tangent, not tan. Okay? They're shortened for your writing pleasure, not your pronunciation pleasure. Okay, mathematicians are lazy. We don't like to write it, even though sine has only got one more letter. We still like to only use as short as possible to get away with it. However, we do say what we want to write, we just don't write it down. Okay, once again, sin is for church. This ain't church. Okay? Questions? Okay, so here we go. Determine the value of all 6 trig functions. So, given a triangle, write the ratios. Here's where students get screwed up. Okay, which one's which? What angle we're talking about? What's opposite? What's adjacent? So on and so forth. Well, the hypotenuse in a right triangle is always the side opposite to 90 degree. It is always the longest. This is my hypotenuse. Okay. Angle theta is down in this lower corner. Opposite means the side opposite that angle. That is the opposite. And adjacent, when you're adjacent to something, you're next to it. This is the side next to it. It is the one adjacent to it. This is not the hypotenuse. Okay, so that's how you set up your 3 sides. Your ratios go from there. Sine is opposite over hypotenuse. 6 over 10, which reduces to 3/5. Always reduce. Cosine, adjacent over hypotenuse. 8/10 or 4/5. Tangent is opposite over adjacent. 6/8 or 3/4. Always reduce. Okay. And the cosecant is the inverse of the tangent. 5/3. Secant is the inverse of the cosine. 5/4. And cotangent is the inverse of the tangent. 4/3.
That's it.
Okay. Got a problem on the next one, though. What's our problem on the next one? We only have 2 sides. We need 3 sides. When you're given 2 sides of the right triangle, you need the third. You always use the Pythagorean theorem. I will temporarily call that x. X squared plus 5 squared equals 8 squared. And no, you cannot take the squared. This does not mean 8 plus 5, x plus 5 equals 8. X is not 3. You must, order of operations, you must square. You cannot just take the square root of both sides. So x squared plus 25 equals 64. Guys, x squared equals 64 minus 25, and I wrote this down because I am lazy. 39. Square root x equals the square root of 39. So this is the square root of 39. You can't simplify it. You do want to simplify it on the test. You'll be told to simplify your radicals. You'll be told to rationalize your radicals, i.e. no square roots in the denominator. You cannot simplify the square root of 39. 39 is 13 times 3. Neither one of those are squares. You cannot simplify the square root of 39. If it was simplifiable, you could. I would, but you can't. Okay, sine, opposite over the hypotenuse. What is the length of the side that is opposite theta in the second triangle? Square root of 39. Square root of 39 over 8. Cosine is the adjacent over the hypotenuse. So this would be 5 over 8. And the tangent would be opposite over adjacent, square root of 39 over 5. Now, the sine, the cosecant, secant, and cotangent are inverses of those. So this is 8 over the square root of 39, but we're not allowed to have square root of 39 in our denominator. So what do? You multiply top and bottom by the square root of 39. After you do that, you get 8 root 39 over 39. And it will not be able to be reduced. Cosine, the secant is the inverse of the cosine. 8 over 5, that's easy enough. Tangent, flip it over. To get the cotangent, 5 over the square root of 39. Multiply top and bottom by root 39. You get rid of the square root in the denominator. And you get 5 root 39 over 39. Question. Your turn, and you have to find the two missing. You have to find missing sides in both of these. Ooh. Quiet. So, Pythagorean theorem, find the missing side. Square root of 97 is the hypotenuse on this one. So you get 9 over the square root of 97. You have to rationalize it, so it's 9 root 97 over 97. The cosine ends up being 4 root 97 over 97. And the tangent is 9/4. Okay. The cosecant is the inverse. Do the inverse of the original, not the simplified one. Square root of 97 over 9. Same thing on the cosine. Square root of 97 over 4 makes it easier. And then the last one, you just flip it over and you get 4/9. On the second triangle, you get 3 root 5, square root of 45, which is 3 root 5. So your sine is 3 root 5 over 7. Cosine is 2 over 7. And tangent is 3 root 5 over 2. Cosecant, flip them over and simplify, and you get 7 root 5 over 15. Secant, that's easy. 7 over 2. And the cotangent, you get 2 root 5 over 15. Is what you'll get when you simplify it. 3 root 5, multiply it times root 5. Root 5 times root 5 is 5. 5 times 3 is 15. So when you simplify it out, that's what you get. Okay? Now, get out your calculators. Here's what you need to do first before we do anything else. On your calculator, take the sine of 45. You should get 0.707. If you do not get 0.707, you were in the wrong mode. You were in radian mode. You need to be in degree mode. So make sure, do this first. If you don't do this first, everything will be wrong. And on your test, if you have it in the wrong mode, because I will remind you on the day of the test to check the mode, and if you have it in the wrong mode because you weren't paying attention to not listening to me, you will get them wrong, and I won't care because you weren't listening and paying attention. Okay, so make sure you're getting this. If you're not getting this, we need to fix it now. Okay, this is all about your calculator. Find the value on your calculator to 4 decimal places. Scarlett. Okay. So, on your calculator, cosine 54 degrees. .5878, rounded off 4 decimal places. Make sure you're getting it. Okay. Sine of 17 degrees. .2924. The tangent of 25 degrees. .4663. Make sure you are getting those numbers. If you're not getting those numbers, then you have a problem, and we need to fix that problem. This is easy. Next one's hard. You do not have a secant button on your calculator, do you? No. Yeah, the secant is the inverse cosine. You have a little cosine with the -1 power on it, right? Normally, something to the -1 power is 1 over that. That is not true with trig functions. Cosine to -1 is not the secant. That is not how you do it. Here's what you have to do. You have to do 1 over the cosine of 64 degrees. You have to do that. On your calculator, do 1. Divide cosine 64.
Not put it in a fraction, divider.
No, do not put it in a fraction. Do 1 divided by that because you're coming up with decimals anyways. 2.2812. Round it off. The cosecant, 1 over the sine of 32 degrees. So you take 1, divide it by the sine of 32. That's how you type it into your calculator to find the cosecant. And you get 1.8871. 4 decimal places. 4 decimal places is standard when you're doing trig functions. That's the standard.
Wait, so how do we know if it's like sine, cosine?
You have to have it memorized, which one's which, for the 1 over. So the cotangent's the easy one.
Yeah.
Cotangent is 1 over the tangent of 73 degrees. And that gives you 0.3057. Yeah, secant, cosecant, tangent, cotangent, you have to just remember which is which. Cotangent's easy. That's 1 over tangent. Tangent, cotangent is easy. Secant and cosecant, it's a little more complicated. Secant, 1 over cosine. Cosecant, 1 over sine. You just have to learn them. Took me a while. I still every once in a while have to stop and think, but you have to learn what they are. So here's what I want you to do now. Do these last 4 on your calculator. 1 over the sine, or 1 over cosine, or 1 over tangent as necessary. Find them on your calculator. Okay. Cosecant is 1 over the sine of 90 degrees, and that's 1. Secant is 1 over the cosine of 33 degrees, which is 1.1924. Cotangent 1 over the tangent of 54.5 degrees, and that gives you 0.7133. Secant 1 over the cosine of 67.1, and you get 0.3891. Cotangent 1 over the tangent of 44.8 degrees, which gives you 0.9930. And the cosecant is 1 over the sine of 58 degrees, which is 1.1792. This exercise is mostly to make sure you know how to use the calculator correctly. That's really what this exercise is about more than anything else. Questions so far? Okay, we're about to go off script. Okay, we are skipping this page because it's basically all the same thing all over again. No need to do that all over again. And we are going to this one, which is not in your book, in your packet. So what you're going to have to do is go to a blank spot on the last page of your packet. Yes, after the summary, there should be a blank spot. And get this written down. Okay, find the angle for the given inverse. So I'll give you a minute. I'll pause and give you guys a minute to get that written down. Okay, so what we are doing now is the exact opposite of what we just did. We're finding the angle. Technically what this means, the inverse cosine of 0.2817 means that the cosine of some angle is 0.2178. To find that angle measurement, we do the inverse cosine. That's what the cosine with the little -1 is. Used to be when I was your age, it wasn't called the inverse cosine, it was called the arc cosine. They changed it to inverse. I don't know why, because then you started confusing people over something in the -1 not being 1 over that object. This is the only time something with the -1 is not 1 over that object. This is not 1 over the cosine. This is the inverse cosine. We're doing the reverse cosine to find the angle. It's very easy to do. You hit shift over the cosine, and you should have cosine to the -1 power, the inverse cosine on your calculator. Then type in 0.2178. And your angle is 77.4 degrees. An angle of 77.4 degrees has a cosine of 0.2178. We're taking the ratio and finding the angle. That's what we're doing. So if I want to do the inverse sine, same thing. Shift inverse sine, 0.5164. And I have a 31.1 degree angle. Usually round off with angles to 1 decimal place. 10. Trig functions to 4, angles to 1. Standard, go figure. Okay, and the inverse tangent. 3.5241. 74.2 degrees, rounding off. Okay. Now, the next ones are basically if I have a 3, 4, 5 right triangle, this is the ratios of the sides for a 3, 4, 5 right triangle. Sine of 3 over 5, that means I'm looking for this angle right there. That's what I'm technically doing on this one here. When you do this, you have to make sure to put parentheses around your 3/5 when you take the inverse sine. You don't have to type it in as a fraction. You can do 3 divided by 5. That will work just fine. Inverse sine, parentheses, 3 divided by 5, end parentheses, and you get a 36.9 degree angle. And do the same thing for the cosine. Shift inverse cosine, parentheses 4 divided by 5, and you get the same angle measurement as you should. Because the cosine of the same angle is that, although I screwed up on the tangent, it will not be the same angle, but it will be the complement inverse tangent of 4 divided by 3, 53.1. (53.1) plus 36.9 adds up to 90 degrees. Okay. Questions? This is muy importante. Notice that we did not do inverse secant, inverse cotangent, and inverse cosecant. Yes, those things exist. They are extremely not useful, so we don't use them. If you do it, whenever you're doing inverse functions to solve a problem, 90% of the time it will be an inverse tangent, followed closely by sine and cosine accordingly. Okay, particularly a real-world problem, the tangent is really almost always exclusively what you use. The other ones come in handy too, but they're not used that much. Do those 6. Okay, that's what you should have gotten for those problems. Gnarly on the video, it goes to blank, all of a sudden, there it is. Okay, that's what you should have gotten for all of those. And yes, the sine, inverse sine of 0.5 is exactly 30 degrees. That is from your 30, 60, 90 right triangle. It has an exact value. There are a couple of them. That is one. Questions? Okay, we do want to get this finished up, so here we go. So last part, solve the triangles, find the missing parts. So I need to find this angle down here, theta. I need to find this side x and this side y. I have to find the 3 missing parts. I actually have 3 given parts. One of them is the 90 degree angle, right? Okay, theta is easy. Theta is 90 minus 66 because the two non-right angles in a right triangle add up to 90 degrees. 90 minus 66. So you get 24 degrees for that. Now, the other 2 sides are a little more difficult to get, but they're not bad, but you have to use your trig functions. Always use given information whenever possible. Don't use found information, use given information whenever possible. So I have this angle is given, this side is given, I want to use those 2 to set up a trigonometric ratio. Sine, cosine, or tangent. To find the side opposite, using side adjacent and opposite, I set up a tangent function. The tangent of 66 degrees is the side opposite over the side adjacent. Remember, the tangent of 66 is just an angle, is just a number. Multiply both sides by 4. X equals 4 times the tangent of 66 degrees. And you figure that out in your calculator. And you get 8.98. So this is 8.98. I want to do the same thing for y. Okay, and I want to use given information, which means I'm going to use this and this. These are the 2 sides I'm working with, which means I want to use cosine. Hypotenuse and adjacent, right? Cosine is the ratio, you use the hypotenuse and adjacent. So the cosine of 66 is adjacent over the hypotenuse, 4 over y. No, I do not multiply both sides by 4. Because if I get that, 4 times the cosine is not what y is. Because y is in the denominator. It does not work the same way. Here's an easy trick. If you have two fractions equal to each other, and those are two fractions equal to each other, are they not? You can swap the diagonals. Y equals 4 over the cosine of 66. If you have two fractions equal to each other, you can swap the diagonals and they will still be equal to each other. You can flip them both over and they will still be equal to each other. So 4 divided by the cosine of 66, 9.83. Questions on this first triangle? Okay. This one's a little harder. I need to find x. I need to find theta. And I like to use alpha. If I have another angle that I have to look for, I like to use alpha for that angle. Alpha and theta. Okay. So I don't have an angle, so I can't set up my trig function. Well, x is easy. X I get using the Pythagorean theorem. 3.5 squared plus 6.8 squared equals x squared. Pythagorean theorem. Hypotenuse is x. Solve for x. X equals 7.6. Okay. Now, I need to find an angle. Given sides, I need to find an angle. I still set up a trigonometric ratio. I like to use given information, so I'm going to use these two. I'm going to start by solving for alpha. If I use that angle here, 3.5 is opposite, is adjacent, sorry, opposite. 6.8 is opposite. So that means the tangent of alpha is equal to 3.5 over 6.8. Which means using our inverse trig functions, alpha is equal to the inverse tangent of 3.5 divided by 6.8. That's why I had you do the inverse trig functions. That's what that is. That's what an inverse trig function is. If I want to find the angle I'm trying to take the tangent of, I do the inverse of what it's equal to. And I get 27.2 degrees. And then I said use given information, which in which case you should set up the tangent of alpha being 6.8 over 3.5. But if you really want to solve for theta by cheating, I really don't care at this point. 90 minus 27.2, and you get 62.8 degrees. And that works for me. You do have 2 problems to do. Do those. Okay, but we are out of time. Bell's going to ring in a minute if I'm correct on my time.